Hi everyone. In this part, we'll take a look at how we can build the CLV pipeline. So far, we spoke about how configuring repositories and adding credentials are more than enough to start building your pipelines using Trel. So let's take a look at the repository that we have added for this purpose. This is the UI for Trel, and if we just go ahead and click repository, we can see that we have added this repository S3US East2 with some parameters that control where all our data will be landing. Okay, so we can now go ahead and start creating the dataset class. We go to add dataset class, and here we have a script that is running in a terminal that's going to automate some of the repetitive portions of this demo. So here, first I'll do this one dataset class manually, and the rest can be automated. Okay, so we're going to save that. So now the dataset class is created. Next, we will add some schema for this dataset class. Copy the schema. Say add schema version is 1. This is a default version, so that if we add any dataset under this dataset class, it's going to have the schema assigned to it. Okay. All right. So now, if we just take a look, we have one dataset class and we have no datasets. If you go over here, it's all empty so far. This is just metadata, and we go ahead and press enter. And our script is going to add the dataset classes, the descriptions, and the schema for the rest. So over here, we can see this stage completed. Okay, so next, let's take a look at the second part, which is data ingestion, right? So far, there is no data in the data catalog, and for Trell pipelines, getting data in the data catalog is the first step. And there are two methods for it. One is an automated sensor. An automated sensor in Trell can crawl and catalog data that lies in S3. But the sensor, and that is how we're going to use in this demo. But but the sensors themselves are more general purpose. They can monitor external data sources, ingest data, and load the data to the data lake, the repository that you have specified, and then catalog it as well, which is a more extensive process. But typically, that is not relevant for a data scientist. Some other team is already doing all the work, and they would have already put the data in S3. All the data science pipeline needs is to recognize that the data is actually stored there and add the data to the catalog. So we're going to be using that kind of a sensor today, further down the demo. But the other way is what we're going to look at right now. Which is manual ingestion. So this involves specifying the path where the data is stored and the classification of the data directly in the UI to add an entry into the catalog. So there are four dimensions that we classify the data with. One is dataset class. The other is instance, which here looks like a date. It need not be a date. In fact, this is actually three dimensions compressed into one for simplicity. But for most of this demo, it's just going to be a date. There's also the label dimension, which is corresponding to the environment of the data. So here we're going to use demo, and we have a repository where right now what we have is S3US East2. A quick correction. A suitable repository is data lake PII, not prod. Prod is more suitable as a label. And this kind of underscores that repositories do the double duty of, the security organization, security enforcement within Trell, giving you a chance to restrict access to certain data in certain repositories from certain people. All right, and after the manually just specifying these dimensions, you can define the schema and validation for the dataset class and add a comment if it is required. So okay, so let's take a look at doing this. So for this, we will click the button add dataset and specify our dataset class. We choose our instance timestamp. We choose our label repository, and then we just have to specify the path, and we are good to go. Okay, so here we can see that the details regarding this dataset that we have just added is visible. It's consistent with the information that we provided. It also see that you can also see that there is tracking of where did the data actually come, this dataset actually come from. It's added by the user. Okay, so now we have added one dataset, and we will let the command this script add the other three datasets. Okay, so at this point, we can take a look at how we can build the clv.features pipeline. Before we get into the clv.features notebook, let us explore Trel's innovative formula-based automation that will run this job. Okay, consider this logical relationship for our CLV feature generation. So the inputs are customer data, some date, demo, and S3US is2. This is the identity of the data that we just added to our data catalog. Let's just confirm that once more. So customer data, date, demo, S3US is2, and it is the same for the other three, and they all have schema version 1, which is also something that we added. So coming back here, what we find is that given this specific set of identities and inputs, this job clv.features will produce a data which is clv.features and the same other three dimensions as the inputs. This is our automation formula for this job. And this automation formula is used by the Trel platform to determine whether or not this job clv.features is ready to run. So here is how it works. So Trel's system is event driven, running as soon as these inputs are present in the catalog and ready, and not really on a fixed schedule. You don't have to provide a schedule to run this job. Given that these identities are present for 9.1, the platform would be able to run this job immediately. And for rest of the days, it would wait until these identities are added to the catalog. Trell uses its catalog to verify the input state readiness before triggering a job, because some of this data may be in incomplete state and they would not trigger this job. Only when it becomes fully created and validated by any data validation rule does the downstream jobs such as CLV features get triggered. Trell's immutable datasets also eliminate concerns about overwriting any existing data, because every time we are running clv.features, this entry is getting created in the catalog with a new path. And if it is the second time you're running this job, the newer path is going to suppress the older path once the newer path is validated. And this formula based automation also simplifies data lineage, because this formula is the lineage of the output. Okay, so this approach allows us to declare the fundamental relationships between our data sets rather than just scheduling tasks. And once a platform decides that clv.features is ready to run based on this formula, it packages all the related information and supplies it to the notebook. So we can take a look at the notebook to see what does a Trell notebook look like, and how does it use, what information is provided, and how does it actually use it. Okay, so when we take a look at this notebook, there is a Trell shared library being imported with some helper functions. So the first helper function we use is get args. And what this is going to do is extract the data that has been given to this notebook as part of running this notebook from the Trell platform, and parse that data and then convert it into a dictionary. Now, in this dictionary contains all the details about all the inputs and output of this notebook, along with a bunch of other metadata information. So we can just use the information that we need. So this get URI function is going to extract the path of the dataset class customer data. If args is empty because we are running this notebook manually just by hitting run, then this function will return this default value. So you are able to run this notebook without any modifications in both production and as a manual run due to these functionalities. So we extract the three input paths, we extract the output path as well as the output entire entry, which contains all the other details as well, including the schema. That is why we really are extracting the entry, because if we don't have this args, this is how we reconstruct a temporary entry, right? We have the URI, and then the entry has the URI, the ID, and the schema itself. So the schema consists of the data types and as well as some validation rule. We have overloaded the schema mechanism with the validation rules as well. And okay, so the first cell after at the end of all of that, it just shows off what is there so that when we actually run this, we can kind of keep track of, if you want to just kind of debug this code, we'll be able to see what is actually processing. Now we load the inputs into some temporary tables, and here we actually do our feature engineering. As I mentioned earlier, we are going to make up a customer lifetime value um, with some uh, just some logic because we don't want to overcomplicate our pipeline. Once the feature engineering and the target variable is created, we're going to just save it in the output URI. But here is where it gets different from typical approaches. We're going to reread this output that we just wrote and run that through validation. So our validation function, helper function, is going to run all the validation rules that are present in this output entry using the Spark context and the soda code library. If there are any, if there are any failures in the validation rule, then this validate function is going to fail, the entire job is going to fail, and that data is basically going to get marked as invalid and will not make it to the catalog. If there are only warnings or if there are no warnings, then the data will make it, and the fact that there were warnings of what they are, all of this information will be available in the catalog. But we will see a demo of that. Okay, so this is how what the notebook looks like. So let's take a look at where we go from here. So next, let's take a look at how we can actually convert this notebook into a Trel job. For this, we have added some template registrations to start with. So how this works is you go to jobs and you hit create job, and it basically gives you a bunch of templates that you can use. We're going to use Databricks notebook, and here we can type the details for this job. Before we do that though, the script is going to actually add the output of our first job, clv features. So we're going to press enter and let it do that. Okay, so just like we added the previous dataset classes, we have now added the output for this one as well. And now we are ready to register this job. Dot features. It's important to use the right job ID for this notebook, and go ahead and get the dataset classes. So here is where we are specifying the formula. Excuse me. The formula for this job, and it is kind of specified in three different sections. The first section specifies the last dimension, the repository column of the inputs. Let's see, let me just finish this. The second section determines the other three dimensions. This is where the real the automation really comes in. So what we're saying is that to run this job, we really need these three things as input, and the inputs have to follow this cron constraint. It should have precision D, and it should have the label demo, and it should start from 9.1, and it is going to generate clv.features. Okay, so with this much information, we are done with this job, and we can go ahead and register this job. Okay, so now that we have done this, we can just execute this job. So when we hit execute, it asks us for a schedule ID. Schedule ID is same as the date that we're trying to run it for. So we have 2024-9/1. We don't have to provide any of this information. All of this is going to, these are basically overrides. And it's always recommended that you provide a comment for every job that you run manually. So first run. So here we see the task report for this task that just got created when we asked for an execution of this job. And we can clearly see that this task has transactions, web analytics, and customer data as input. And we don't have any output yet. So even though it's part of the formula, you can't see it unless it is valid. And we are waiting to run this job. Okay, so we can take a look at job runs over here and then see what is going on. So this is the job that we just started, and what's happening is that the cluster is being spun up to run this job. So we'll just skip a little time until this job actually completes. All right, we're back, and what we see is that this run has actually completed. And if we take a look at the actual run, we can see more about how the Trel automation actually performs. So here we see some of the details. We can see the final outputs, URIs that got selected. Here we can see some of the important parameters, clv.features, the schedule ID that we are running, task ID, any additional arguments that were passed to this job from the registration or the command line, and task comment that we provided. And here's a lot of additional information, attempt information, the complete details about the inputs and the outputs. And all this can be relevant when you're actually trying to run this job and you're dealing with some complex cases. So Trell doesn't hold back any information from you, gives you everything you could possibly need, let you decide what you actually need to use. Okay, so when we refresh this, we see that the run has succeeded. We have clv.features, and we actually see that the comment of the job has been passed on to the output data set as well. So this is a very convenient bit of mechanism where you can just look at the data set and you can see the comment that is related to creation of this data set. Okay, we can also see that this dataset passed all the 9 validation rules that is applied to it, and it got a green check mark for it. Let's go back here and take a look at this job. Right now it is set to manual runs, which means that it'll only run if I do execute over here. But we have the option of enabling the scheduler. Let's go ahead and do that. And we can trigger the scheduler as well. This means it's basically backfill, that you're looking at all the data sets that we currently have in the catalog and then just filling or just running the job on all of them in parallel, and then just getting all the results in the catalog. But right now we only have one date and we already ran it, so this is not going to do anything. The reason, uh, and we ideally the way it's supposed to work is you're supposed to add all the input data sets for all the dates that you have, and we will look at a number of dates during the demo, but I don't want to add all of them right now because I have things to do with those dates. For I'm going to be using them for various aspects of the demo. So but in practice, you build a job, you backfill the job, so that when you write the next job, you have high quality data to write the next job on, and you're not just writing it on top of assumptions about what this job would have done in production, right? So a very like a strong foundation for building the next job is available to you when you're using Trell and you use the backfill mechanism. But don't worry, we will do the backfill once we finish all the jobs. All right, so let's go ahead and press enter. And let's take a look at the modeling notebook. There are a few changes for the modeling notebook. So first of all, we only have one input that we are needing clv.features, but we have two outputs. So we have clv.model and clv.model metrics. So we need the entries for both of them. And what we are also going to do is we're going to combine the additional arguments and the CLI into one list, and we're going to treat this as a command line and have it be parsed by an arc parse to give us, whatever information that we have provided on there. We're going to use these two parameters for iteration and depth of the modeling process. And if we're just running it directly as a notebook, then we can have some defaults for all of these, including the schema. And here we can see the schema of the validation rule. We have RMSE, MAPE, and R2. This is because the validation the model metrics dataset that we have is actually storing the details about the model, and what we really like doing is running validation on those details to make sure that those details are satisfactory for our needs. So in case they are not satisfactory, we would consider the validation to have failed. Okay, so here we have some little extra additional feature engineering. You could ask, like, why are we doing this here? Why not in clv.features? It's a little interpretation. You can consider clv.features to you could require that it does all the feature engineering, but in this case, we're just doing largely data integration in clv.feature engineering, and some of the model specific tweaks to the features are being done in the modeling job itself. And now we are going to just select the features that we want, and we are going to run the model building process. Um, and finally, once a model is built, we're going to apply the model on the test data and start generating some statistics. So all the statistics here. So here is one cool aspect of Trell. You can construct a comment for the output data sets that contain all the information about the input parameters as well as the final results, and this can actually be added as a comment to both the output entries, and this will exist there in addition to the task comment. So once the commenting is done, we go ahead and write the metrics output, and then we reload it, and then we validate our metrics using our validation rule. So if the validation rule passes, then we go ahead and write the actual model itself to the output. It doesn't really matter even if you do it earlier, but this saves time if it's not going to be needed anyways. On second thoughts, maybe you want to put the model writing a little higher before you fail, so that in case you want to debug what does the model actually do, why did it actually fail, you actually have the data to investigate it. So yeah, you could do it either ways. And that is the end of the notebook. That is all that is needed. Okay, so this corresponds to this slide. And now that we have seen the notebook, let's go ahead and add the dataset classes for the output And let's also just go ahead and do the prediction as well. Predict now that we've seen the um, data preparation and modeling, prediction is not particularly interesting. So we can see the dataset classes getting added, um, and the jobs getting registered. So the way you registration command line is you should have a the file, the YAML file locally, and then just say trel register, and that's going to take care of that. And we're going to enable the scheduler for them as well. So next we're going to see how this actually runs in a fully automated fashion. So what you notice is that this was fully scheduled, and now all of these are scheduled as well. So, but is anything running? So, what we see is that nothing is actually running is because we still don't have any data to actually process. We just have clv.features. Um, we have the clv.features for 9.1. So, this can actually run for 1 day. So, if we go ahead and trigger this scheduler, that is exactly what we notice. So, if you come here, this has picked up the clv.model job, and if you wait for it, it's going to then pick up the clv.prediction job as well. So let's just wait for a little bit and let that complete. So this job that just finished the model creation, and the prediction that follows it also ran and finished completely. So if we come over here, we take a look, we have features, model, and predictions all completed. The entire pipeline has run for 9.1. So now we want to kind of run it for a number of days. And for that, we need a lot more data in our catalog. And for that, we need the sensor. So let's take a look at how we can add a sensor. So to add a sensor, we go to the sensor section of Trel and then click Add Sensor. So we have a template called S3 path that we're going to use to configure a sensor. And we need one sensor per dataset class, and the rest of the dataset classes, rest of the sensors will be created by the script. So we go ahead and just fill in the blanks. Uh, we're going to do transaction history first. So this says, what is the code of the sensor that we're using. The code is from our open source library. And let's not get into this right now, but we'll focus on this section, which is how to catalog the data that the sensor actually finds. So that's also clear. It's transaction history. Uh, this is now this should be demo. This should be S3 US East 2 instance format. So the data is in folders of YYYY um, and then this is where we are actually going to look for the data, and this is the prefix. And finally, this says if we find a folder with some files in it, how do we know it's actually a complete data set and not just any complete one? And you can have a number of rules, and the rule that we're going to put is success criteria. Sorry, success file. Okay, so we registered that, and now we have this one sensor, and it's turned off. So we're going to turn it on, and let's see what it looks like. So it's starting, and as soon as it starts, actually, it says that it has found four transaction history datasets until 9.4. So if you go ahead and see here, we see that it has found 3 more days of transaction history. That's great. We didn't have to do anything manually. And we're going to go ahead and let the script add the remaining sensors. So it's going to add 3 sensors and activate 2 of them. And we're going to see them uh, over here. Right. So 9.4, and actually, they all have data until 9.6. Transaction history only has until 9.4, and customer data we haven't really enabled. So what we're going to do is, and so far, because you have every data except customer data for these 3 dates until 9.4, we still don't have any runs that are happening. But if you go ahead and turn the last one on, let it load the data, you can see how quickly it actually responds to data availability. So it has virtually immediately run the clv.features for all 3 dates. And these are going to execute in parallel. And if we had configured clv.features not use a static cluster, but sort of like it was a different type of job which would spin up its own cluster for every task, then all these 3 jobs would execute in parallel in separate resources and then complete at the same time. Okay, so we'll go ahead and finish this, but this is the end of the video. And in the next video, we're going to look at some more complicated, some simpler maintenance use cases. We're going to look at some data quality related stuff. So stay tuned.